Welcome to Solving Trig Problems, Part 2. This is notes number 1. Okay, before we get started, I want to remind you on your calculator, you want to make sure that you are in degree mode. So as a reminder, the mode key is next to the second key. So if you hit mode, right here you have a choice between radians and degrees, and you want to be in degree mode. Okay? All right. When we solve equations in math, we learn about inverse operations. For example, if you have x plus 3 equals 5, in order to solve this, you have to do the inverse operation, which means how do you undo addition? Well, to undo addition, you would subtract. Subtracting is the inverse operation of addition. If you had a question like 2x is equal to 10, this operation here is multiplication. To undo it would be to divide. Dividing is the inverse operation of multiplication. Well, the same idea is going to be true with trig functions, right? We have the cosine of angle A is equal to 0.678. We know that the cosine of an angle is equal to a ratio adjacent over hypotenuse, right? But we want to solve for this angle. This angle is a part of this trig function. You cannot just subtract it out or divide it out. What we have to do is we have to undo the fact that we're taking the cosine of the angle. And in order to do that, we have to use cosine's inverse operation. So what we're going to do is take the inverse cosine of the cosine of angle A. Cosine with the little -1 up here. That's the inverse cosine. And what you do to one side, you have to do to the other side. And when you take the inverse cosine of cosine, you are left with angle A. And then this side, we're going to just put in our calculator. All right? Now, on your calculator, you have your trig functions right here, sine, cosine, and tangent. And right above them are their inverse trig functions. They're in blue, so I'm going to use my second key. So I go second cosine, and you see up here how there's a -1. That's the inverse cosine of 0.678. And that's going to give me 47.3 degrees. Okay? All right, well, let's look at another trig function. This time, let's do the tangent of angle A is equal to 4/9. I know the tangent of angle A is equal to the ratio of the opposite over the adjacent. If I want to solve for angle A, I'm going to take the inverse tangent of both sides. When I take the inverse tangent of the tangent function, it undoes the tangent function, leaves me with my angle. And on this side, I'm going to come back over here to my calculator, go to tangent, and I want the inverse tangent. So second tangent, you see how it shows it to the -1st power of 4/9. And I get 24.0 degrees. Please make sure that you are trying this on your calculator and confirm that you are getting the same answer as me. We can now take this concept and use it to solve for angles in a triangle. For example, here is a right triangle. I have 2 measures of sides. and I am going to solve for angle A. All right, so I'm going to write that down. Find the measure of angle A. Just like we did before, you always look at your angle. Even though you don't know what the angle is, you look at your angle and you look at what sides you have. So I have the opposite side and I have the hypotenuse. And remember, SOHCAHTOA, if I have the opposite and the hypotenuse, that would be the sine function. So I know the sine of my angle is equal to the opposite over the hypotenuse. This time we are solving for an angle. And if you remember what we just did, in order to solve for the angle, angle A is going to equal the inverse sine of our ratio. So using my calculator, I need the inverse sine, so I'm going to go second sine of 12 over 17, and I get 44.9 degrees. Sometimes in your trig problems, they will ask you to solve a triangle. What this means is to find all sides and all angles. Let's look at an example. Here is right triangle ABC. I'm given 2 out of the 3 sides of the right triangle. I want to solve this triangle, so I'm going to start with finding the measure of angle A. Okay. Again, you look at the angle and look at what you're given. I'm given an adjacent side and I'm given the hypotenuse. Well, using SOHCAHTOA, adjacent and hypotenuse is going to be cosine. So the cosine of angle A is equal to the adjacent 6 over the hypotenuse 15. I'm solving for an angle, so I'm going to use the inverse cosine. I'm going to use my calculator, and the inverse cosine of 6 over 15 is 66.4 degrees. Now I'm going to take that measure, I'm going to put it up here in my picture. Now hopefully you can see, to find the measure of angle C, I know this angle is 90, so I know these 2 angles have to add up to 90. So all I have to do is do 90 minus 66.4, and I get 23.6 degrees. All right. Now again, to solve a triangle, I need to find all the sides and all of the angles. So I still need to find side BC. Okay. Well, you need to always start with an angle. So I'm going to start with angle A. All right. And I'm trying to find side BC, which is opposite. And 15, I have a hypotenuse. So if I'm starting with side A, I'm going to use the sine of side A, angle A. Opposite is side BC. Hypotenuse is 15. And if you remember to solve this, I'm going to put sine of A over 1, and I'm going to cross multiply. Side BC is equal to, cross multiply, 15 times the sine of A, and we know what A is. It's 66.4, because we just figured that out over here. And therefore, using my calculator, I get 13.75. And I have solved the triangle.